2023 projectile motion, let's do it. The next batter hits a ball up in the air with an initial velocity of 22 meters per second at an angle of 35 degrees. Show that the vertical component of initial velocity is 12.6 meters per second. Okay, so this right here is the resultant velocity that the ball is traveling at. This means that this is the combined or the result of our horizontal velocity and our vertical velocity. So combining those two components together, we get the resultant of 22.0 meters per second. We have to prove to the examiner that this initial vertical velocity is 12.6 meters per second. How are we going to do that? Well, we're going to have to use trigonometry to figure out this side of the triangle. When we are using trigonometry, we need to label the sides of a triangle. So we know that this side over here is our hypotenuse. Opposite the angle is our opposite. And then we've got our adjacent, which is going to be in between these two angles over here. We've been given a hypotenuse and we want to figure out what our opposite is. So what is the trig function that we're going to have to use? We have to use SO, aka our sine function. The equation for that is sine theta equals O over H. Substituting everything in, we've got sine 35 degrees equals opposite over our hypotenuse, which is 22.0. I want to get rid of this divide by 22.0, so I'm going to multiply it by itself to cancel it out, and that means I have to multiply this side of the equal sign by the same thing. So what I'm left with is 0 equals 22.0 times sine 35. Plug that into your calculator and you should get 12.6 meters per second. So VI equals 12.6 meters per second, and any time you're given the value to begin with, it's so important to show you're working, okay? To convince the marker that you know what you're doing and you got to the same answer that they want you to, achieve. B, calculate the maximum height reached by the ball above the ground. Okay, so the maximum height from the ground is essentially a distance value, okay, in the vertical plane. This is what we want to figure out. How do we do that? Well, the first thing that you should consider is drawing a table, okay? I know it can seem a little bit tedious or unnecessary, but it just clarifies your working a little bit. So we've got our horizontal stuff on the left, and we've got our vertical stuff on the right side, and this is what we want to focus on. We want the vertical distance. That's what we need to figure out. What other information do we have to be able to work out this vertical distance? Well, we just worked out that the initial velocity is 12.6 meters per second. What about our final velocity? Well, we want to find out the vertical distance over here, right? Okay, so if this right over here is our initial velocity and we want to stop over here, okay, this is going to be our final velocity. And our velocity at the top or the peak of an object's flight is always going to be 0 meters per second. Okay, velocity at the top comes to a stop, so 0 meters per second. What other information do we have? Well, we know that acceleration due to gravity is 9.8 meters per second per second. What we have to do is we need to look at our resource sheet. What kinematics equation is going to be the most appropriate to figure out what our distance value is? Take a minute, pause, try pick one. The one that I have picked out is going to be VF squared equals VI squared plus 2AD. Okay, this uses all of this information. Right, before we substitute things in, okay, what we have to figure out are positive and negative vectors, okay? And so, remember what I've taught you, always make the velocity that your object is going in a positive. So, because initially the ball is going upwards, we are going to define this as a positive value. So, VI is a positive value. The other vector that we have to be thinking about is acceleration. So, velocity is going up, but acceleration due to gravity is going down. It's opposing our velocity. So, we have to define our gravity, our acceleration, as a negative, okay? So that's my tip. Always make the velocity of your object a positive, okay? Even if it's going down. Always make velocity positive and then look at acceleration. Is acceleration opposing that velocity or not? If it's opposing it, it's going to be negative. If it is not opposing it, if it's going in the same direction as your velocity, okay, then it's going to stay positive, okay? So, now that we've determined our positive and negatives, we can now comfortably substitute everything in. So VF, as we can see in our chart, is 0 squared. VI is 12.6 meters per second plus 2A, which is negative 9.8 times distance, our vertical distance, which is what we're trying to figure out essentially. What I've missed is this little square, okay? We need to not forget about that part of the equation. All right, so we need to figure out the distance. My analogy of an onion suggests that if this is the core of the onion and we want to get to it, you need to peel back the layers from outside in. So that's the core. We've got this next layer over here. Then we've got another layer over here. And then we've got our final layer over here, okay? So we need to peel an onion from outside in. That's the only logical way to peel an onion. And so let's start off by getting rid of this first layer. So currently we've got a plus 12.6 squared. So to get rid of plus 12.6 squared, we need to minus it from this side. That means we need to minus it from this side of the equal sign as well, okay? So that gets rid of this. And what we're left with is 0 squared minus 12.6 squared. And so that is going to equal negative 12.6 squared, okay? So let me write that in black. Negative 12.6 squared equals 2 times negative 9.8 times distance. Okay, so now we're up to this layer of the onion, our red layer, okay? But as you can see, this red layer is being times by this green layer, so we can simplify it. Any situation where you're multiplying things, you can squish them together and simplify this layer, okay? Why make life more difficult? Let's simplify it. So 2 times negative 9.8 is going to be negative 19.6 times D. Okay, we've simplified that layer, and this is what our equation looks like right now. So now that I've squished these two layers together, I could get rid of this thing altogether to be left behind with the core. And so we've got negative 19.6 times D. To get rid of times by, we need to divide this whole side by negative 9.6 to cancel it out. That means we need to divide this whole side by negative 19.6. Okay, So what we're left with is d equals negative 12.6 squared over negative 19.6. Plug that into your calculator. What do you get? You should get 8.1 meters. Don't forget your units. And so we know, if we go back to the question, okay, calculate the maximum height the ball reaches above the ground. This is going to be 8.1 meters. That's pretty high. Okay. So now that we've done these parts over here, let's move on to part C. The ball's motion can be tracked and shown as a parabola motion. Use physics principles to fully explain the motion of the ball from the time it leaves the bat and hits the ground. The first thing that we need to do is show appropriate arrows of appropriate length to show the forces on the ball at A, B, and C. Okay, I'm just going to draw everything that I can, and I want you to do the same, so take a minute to pause if you would like to, or just follow along with me. So if we're looking at VI, okay, or velocity in the vertical plane, at point A it's going up, okay. At point B, remember, the vertical velocity comes to a stop, so there's no vertical velocity happening right at this point. Okay, so I'm not going to draw an arrow. At point C, the vertical velocity is now in the downwards direction. Okay. The next arrow or vector I want to be drawing is our horizontal velocity component. So at all points, remember that this is going to be constant. This is going to be constant. Why is it going to be constant? This is because gravity has no effect on the horizontal component. All right, gravity only works in the vertical plane, which is why the vertical velocity, okay, gets slower, or it reduces by the time you get to the top. Okay, so here we have it. We've got acceleration in the downwards direction. And it's always going to be 9.8. I might label all these things. So we've got our velocity initial, we've got our velocity final, and then we've got our, I'm going to do VV for vertical velocity, and then we've got our horizontal velocity over here. Okay. So that's all fine and dandy. The next thing I want to do is describe and explain how the forces, acceleration, and horizontal and vertical velocities of the ball change throughout its flight. So we've already kind of discussed this, okay? So I'm just going to talk through it again, and you can take your own notes. So, forces, there are no horizontal forces. This is because gravity only works in the vertical plane, okay? In terms of acceleration, this is 9.8 meters per second downwards. Horizontal velocity is always going to be constant, okay? This is because gravity doesn't impact it. Vertical velocity, so I want to explain it at point A, B, and C. So at point A, the vertical velocity is 12.6 meters per second. At point B, the vertical velocity is 0 meters per second. It's reached its maximum height, okay? It's not going further. At point C, vertical velocity is constant but faster than VI in the downwards direction, okay? So there we have it, okay? We have tackled projectile motion 2023. And that's not too bad, is it? I'll see you in the next projectile motion video.